Welcome to the Pachehra Talks. My name is Arun. I'm Solutions Architect, MCT, working with Novin Tech, which is one of the best organizations to work with. And today we are going to talk about Application Gateway. It is a security series, so we'll focus on the security aspect of Application Gateway after talking a little bit about it. And if you would like to go deep dive about Application Gateway, you should see the AZ admin or AZ 104 certification syllabus, or you can simply go to YouTube, type Pachera Talks, search for it. And once you have this channel in front of you, click here and go to the playlist. Under the playlist, you'll find a deep dive application gateway playlist. You can go through it. Uh, and you have all those labs and everything here, and it covers almost everything. It is a deep dive in application gateway. But this series, as I said, we are not going to just repeat the same thing again and again. We are going to talk about application gateway from the security aspect, because this is security specialist series that we are talking about. So before we start hitting security aspect, let's just briefly introduce application gateway. So application gateway is what? Application gateway is a smart load balancer, you can say, or a smart web traffic load balancer that enables you to manage traffic to your web application. In a simple way, let's suppose this is a client who is trying to access some website. It will request request will come here on the application gateway IP address. And then as per the rules and regulations that we have applied here, not the and as per those routing, it will fall to this VM or this VM or this VM. Okay. Everything is covered in those playlists that I've shared you. So this is what the application gateway is. It's a smart load balancer. Why smart? Because it works on layer 7. So that means it is aware what is going on that data on layer 7. What exactly I mean by that, I'll tell you. For example, one of the feature of application gateway is URL based routing. What it is? URL based routing, which simply means if you are browsing a site with the URL, let's suppose slash images, okay, slash images xyz.com slash images, you can say. So, or you may be typing xyz.com slash API, okay. These two are the different URLs. So your application gateway is smart enough to understand it is a slash images or slash API, because it works on layer 7. So when your client types images.com, it will go here and it will send this traffic to that particular pool, backend pool, which serves the images. Okay. Similarly, if your client try to access xyz.com slash API, then again, this will land here. And as per the routing rule, because it can understand it is API, it will send to the VM, which is hosting, or backend pool, which is hosting slash API. Okay. So it's a smart load balancer. It can understand. So what actually we are achieving this? Well, first of all, single application gateway can carry multiple backend pools, and it will increase the application responsiveness and efficiency by routing requests to the best suited server. So it will help you achieve that. The first routing rule is application URL based routing rule. Okay. Now, and it shows that it is a smart load balancer. Now, it can also do host based routing. What it means, it simply means multi-site. A single application data can be utilized to host multiple sites and the backend. So for example, if this guy is trying to access xyz.com, okay, or maybe xyz.net, okay, any of those on the same application gateway we can host. both these sites. So if it is trying to access xyz.com, application gateway can understand, oh, it's xyz.com, and send it to the traffic, which is backend pool traffic, which is hosting xyz.com. Okay. So host-based routing allows each domain to be directed to its respective backend pool without needing multiple gateways. So simplifies multi-site hosting, reducing infrastructure cost and complexity. So that's a second way of routing, the intelligent way of routing. All right. So what else? Well, it can also help you. For example, this HTTP redirection or redirect configuration. You can choose redirect configuration, which simply means all the traffic comes like HTTP, it will redirect it to HTTPS. So uh, this this redirection all HTTP traffic to HTTPS will ensure that all the encrypted traffic or encrypted connections for all users will reach to the destination, and it will enhance the security, of course, and meet compliance requirements for the encrypted data transmissions. So that can be done. So everything would be HTTP to HTTPS redirection. Now, this is another feature. Now, there is one more which is called session affinity, which simply means affinity, right? Affinity of a session, or we can say cookie based affinity, the things like that. If this client access something, let's suppose it's a basic configuration, and as per the routing rule, this is landing to this VM. Now, if the session affinity is enabled, that means whenever this client access this, it will land to this VM only, and it is cookie based. So as per the cookie, it will figure it out. Okay, this guy was landed to this VM, let's send it to this VM. So this kind of feature is also there. Now, there is one more thing, and this, of course, improve user experience by maintaining session state, and it's critical for the consistency of transactional data. It used not so frequently, but yes, if somebody needs that kind of configuration, it is available. Now, there is one more thing which is very important, because why? Because all those backend VMs that we have, or backend pools, needs to be upgraded. There needs to be maintenance taking care, right? If we are trying to maintain this VM, for example, we need to turn it off and do some update, patch, whatever. So what will happen for all the requests? For example, this guy come here, request something, and this app gateway sends here, and it is the time where we are going to perform the maintenance on this VM. So what will happen? We can, if this uh, connection draining is enabled, then all those requests which is landed here, for example, this client, there would be another client here, right? He is also trying to access, and this lands on this VM. Then connection draining will start draining this connection, will not accept any more connections. And during the time that we have decided, selected, once this connection is end, the maintenance window will start. So when updating server software, connection draining ensures that existing connections are not dropped immediately, allowing users to complete their current activities. So it ensures a smooth user experience and minimize service disruption during the maintenance activities. So this kind of feature is also there. All right, so there is one more thing which is called SSL termination. Okay, we're just getting ourselves familiar with all these features of application gateway. Deep dive has already shown you why we are doing this, so that we can actually talk about the security aspect of application gateway. That's the goal for this video. So SSL termination, it handle this app gateway handles SSL termination at the gateway rather than at the individual app server. So the request comes here, and this request is encrypted. But here on the application gateway, we have cert enabled, and we can decrypt the this request which is coming here. So this request gets decrypt, and then it gets sent to the backend pool as per the routing rule. So what happens? Offloading the SSL processing here, processing over what will happen? The processing overhead from the backend resources will come here. So it will save the CPU cycle for you. So SSL, so okay, securely manage SSL certificates in one place and reduce CPU load on backend servers, which no longer need to encrypt and decrypt traffic. We can easily achieve with this. So how it can help us? It will simplifies certificate management and improves web server performance, because here is the uh, uh, securely managing the SSL certificate in one place, increasing the performance of the backend servers and securely managing the certs. We can also have application, not the application, but something called key vault and MI, so that this guy right here will access cert from here rather than here. That can also be done. All right. So SSL termination can be done here and it will help. And the final feature, which is most important from security aspect, is WAF, which is Web Application Firewall, which protects application from common web vulnerabilities and exploits by integrating WAF. It's a particular SKU that you need to select. And this will automatically blocks or detect or prevention are the two modes that you can opt for. Ideal way is always go for the detection, keep watching for a week or a month, and then apply the detection, because you don't want to interrupt your production environment. So attacks such as SQL injection or cross-site scripting, all those OWASP attacks. So it will definitely enhance the security without requiring changes to application code, because this is attached to the application gateway from where you are actually exposing the exposing application of 443. So these are some basic information we just talked about, and getting ourselves familiar with the application gateway, and you know where to go for the deep dive. But now it is time for the security security aspect of app gateway. Okay, let's start something one by one. So the very first thing, we can start with SSL. Okay, we were talking about here. So SSL termination. So SSL termination is a process where an intermediary device, here it is application gateway, decrypts the SSL TLS encrypted traffic before passing it to the backend server. We already talked about it. Traffic comes from here, is browsing. Here the decryption happen and then it will send to the VM. This is what it actually is. So what it does, this offloads the SSL decryption task from backend servers. Okay, here it's supposed to happen, but now it will happen here. So it will offload it and improve the performance and simplifying the SSL certificate management. Because you have multiple VM, then you have to do multiple cert on all those VMs where the request will land. But now here on the app gateway, it will taken care at the one point. So when a client initiate HTTPS request, this client is initiating HTTPS request. The SSL termination point at the application gateway intersects this request right here. Okay, intercepts. Then the gateway then decrypts, intercepts, and then decrypts the request using the SSL certificate it holds, because it has the capability to upload right here, and of course the other way that I talked about. So after decryption, the application gateway forwards the plain text request to the appropriate backend server. So request which is coming here is in plain text now. Okay, now it could be HTTPS again depending on the configuration, but this is what the SSL termination means here. But it could be end-to-end encryption as well. So we do have this security feature here. So how exactly it is working? Well, client or user accessing a banking website, let's suppose xyz.com in the browser initiate the HTTPS request, and request lands to the application gateway. Now, app gateway receives the HTTPS request and performs the SSL handshake using the SSL certificate associated with that uh, xyz.com. Now it decrypts the traffic to plain HTTP, and the decrypted HTTP is forwarded to the backend server. All right. This internal communication can be over HTTP or secured again with HTTPS. That is possible, and depending on the sensitivity of the data, the internal security policies that would be decided. So what happened? The backend server process the request and generates a response which is sent back to the application gateway. And if the internal communication was over HTTPS, the response is decrypted by the application gateway here. Now, before sending the response to the client, the application gateway encrypts the data using the same SSL certificate, converting it to back into the HTTPS response. Now, the user browser receives the encrypted response. It has been encrypted there on the app gateway. So what could be the best practice here? Centralized SSL management. So store and manage SSL certificate on the application gateway or key vault. End-to-end encryption for highly sensitive applications. Consider re-encrypting traffic between the app gateway and the backend service to ensure data protection throughout the entire path. Or regularly update and replace your SSL certificate. Deploy application gateway instance across multiple availability zones and at the auto scale mode. These are few things that we can think from the security and the other best practices perspective. Now, the another security which is very important, which is the most important because this is what will take care of WAF layer 7, even the layer 7 DDoS as well. Yeah. So the web application firewall on Azure Application Gateway provides centralized rule-based protection for your web application from common web threats and vulnerabilities. We already talked about it. So operating at the layer 7, uh, WAF examines HTTP and HTTPS requests to your applications against a set of rules that identify and block malicious traffic, protecting against attacks such as SQL injection, cross-site scripting, and others defined by the OWASP core rule set. So what is happening here once the request comes? It will examines or scans and block or allow accordingly that we have selected. So this is what happens at the app gateway. We can simplify this entire flow. A user attempts to submit a request on a web application hosted behind the application gateways with the same flow. The request is intercepted by the app gateways. Now this time it is WAF feature. Okay, the WAF inspects HTTP or HTTPS content against its set of rules. In this case, it identifies the request as a, let's suppose, SQL injection attempt to based on patterns defined in the OWASP core set rule and maybe block the request. All right, so what could be the best practices for the WAF here? Well, it could be start with the default OWASP core rule set for broad protection against common vulnerabilities, customize or disable specific rules based on your application's needs to minimize false positives without compromising security, of course. Then keep the WAF rule set updated to protect against newly discovered vulnerabilities and attack vectors. Use detection mode to log attacks without blocking them when you are turning your WAF policy. Switch to prevention mode to actively block detected threats once you are confident in your rule set's accuracy because you don't want to block the important websites or URLs for your production applications. Now, regularly test your WAF configuration in a staging environment to ensure that legitimate traffic isn't blocked false positives and that malicious traffic is effectively identified and blocked. So, leverage custom rules for specific application requirements or to address unique threats identified through the log analysis and monitoring. So, that is about WAF. What is other security thing that we can talk about on app gateway is the HTTP listeners. Yes, HTTP or secure HTTP listeners on app gateway are designed to handle incoming HTTPS traffic, providing a secure communication channel between clients and the application. These listeners are crucial for implementing SSL or TLS termination, ensuring that data transmitted over the internet is encrypted and secure from eavesdropping or tampering. So, that's what this HTTP listener does. Secure HTTP listener are configured to listen to HTTP S traffic, okay, on a specific uh, port. Typically, port 443, the standard port for HTTPS communication. They require an SSL certificate to be associated with them for encrypting and decrypting traffic. So we need SSL here as well. By using secure HTTP listeners, App Gateway can terminate SSL or TLS connections, offload the SSL processing workload from backend servers, and inspect the traffic from routing decisions or WAF processing. All right. The decrypted request is sent to the selected backend server in the pool as per the routing decision. All right. So, what could be the best practice here for our this friend? Well, of course, SSL management or certificate management. Regularly update and manage SSL certificate on App Gateway. Configure SSL policy on App Gateway to use strong cipher suits for encryption. Consider re-encrypting traffic between App Gateway and backend servers for sensitive application to ensure data privacy throughout the entire communication path. And of course, enable logging for secure HTTP listeners to monitor SSL handshake failures or certificate related errors, and deploy app gateway instance across multiple AV zones, which remains the same as per all other features, because this will provide this is constant for all the features, providing one more instance, more than one instance, like a scalability, like any other scalability feature. Now we have one more thing which is called IP restriction. Yes, you heard me. IP restriction and network filtering. So IP restriction and network filtering. All right. I hope you are getting everything with the name already. So let's talk about it. So this IP restriction and network filtering are security mechanism on Azure App Gateway that control and manage access to web application by defining which IP addresses are allowed or blocked. IP restrictions allow you to specify a list of, or you can say whitelisted or denied or like blacklisted addresses or ranges for accessing your app. Network filtering, on the other hand, involves using Azure's native capabilities like NSGs. Yes, you can apply that now to enforce traffic filtering rules at the network level, further controlling access to the application gateway and backend application. So NSGs and whitelist or blacklist, you can have that. So, what could be the best practice for this? Well, keep your list of allowed or blocked IPs current to ensure that only legitimate traffic can access. Limit the number of open ports on your NSGs to only those necessary for your application's operations. Group related virtual machines using ASG and NSG. These are like the best practice of NSG and ASGs. But yeah, you got to utilize Azure Monitor and Azure Security Center, or you could say MS Defender, to regularly review access logs and detect unusual access patterns or potential security breaches. Use IP restriction network filtering in conjunction with your Azure Application Gateway security features such as WAF and SSL termination for a layered security approach. All right, so yeah, these are some wonderful security features. There could be one more. We can put it here in the security feature because it can hamper the existing connections. Well, if you are thinking about draining, then you are correct. Connection draining allows the backend servers being removed from the pool to complete processing of in-flight request while not accepting any new request. This is especially important for applications that maintain stateful session or have long-running operations. So How it happens? Well, a user starts a transaction on the web application, which is routed through the application gateway to the one of the backend server. Right? That's how we have learned as of now. So let's suppose an update is scheduled for the backend server, which means temporary removal from the backend pool. So connection draining is enabled on the app gateway for the affected servers. The servers marked for draining stop receiving new requests from the app gateway. However, they continue processing any requests that are already there. Now, new client requests are routed to the other and undrained servers in the backend pool. Now, once the request is done, the draining servers complete processing of the in-flight request. The responses are returned to the clients through an application gateway, ensuring that the transaction session is not interrupted. Once all in-flight requests are processed and no new requests are being sent to the draining servers, they are safely removed from the backend pool for maintenance and updates. So these are the wonderful, wonderful features, and we talked about a lot of security aspects of App Gateway, and this is what we supposed to talk about in this video. And you know where to find the deep dive. Here, right, it is. You can say all those labs and everything is covered in detail on the same channel. Well, I hope it was interesting and you enjoyed the security aspect of application gateway, and you know when to use whenever you're exposing your application outside so that people are accessing uh, your application on public IP outside. You can use application gateway, but you can also use it internally because it can also hold private IP addresses. We place this inside the virtual network on one of the subnet. There are multiple ways we can have settings that will be talking about in this series. Like if you talk about the entire architecture, where exactly we should place application gateway in a hub or in an individual application. Shall we put it above the firewall or below the firewall? Who will come first? Application gateway or firewall, or do we need it parallel? Configuration. We will talk about all those design architectural decisions from the security perspective in our upcoming video. For now, that's it. Thank you for watching, and you guys have a wonderful day. Bye bye.